Hello, I'm Chris Athanas. These cameras are all messed up. Today we're getting into. I'm a KMP developer, and today we're going to be getting into bad programming ideas from C++ and Java. That's what we said, and Java. And update on the portal. Good news. They had some sort of new technological breakthrough at the new company. And so they're redoing their whole tooling and everything like that, and they're gonna have to retrain the company on this new AI tech, and then they're gonna get that tool that they need updated with the new AI tool to go close this portal. So eventually, I hope that one day we will have that thing closed. Okay, today we're getting into I'm gonna be reacting to this video about this keynote from Abstraction Patterns. Ugh, terrible title. It's a terrible title. About Kate Gregory from TechTown 2022. And I was really surprised to find out how much of this stuff is still being used in business and industry and whatever. She says all this stuff is still being used. So I did a catalog of the 12 things. I need to add that 12th one here that she brings up in this talk, and the talk is specifically about C++, but this is all like stuff that's I've seen in Java quite a bit of people. It seems like this is the most common way. This class, either the procedural style, which is very useful, don't get me wrong, and probably 99% of the time is probably all what you need, and then they get into the C++y stuff, and they go nuts with it, and then they add all this stuff that doesn't make any sense, and don't use other things too. So let me get into it. Let's quit waffling. Get into it. Let's go.
Here's the thing. We teach abstraction. We kind of lie. Here are the lies we tell people. You find your abstractions before you write your code. You have to write them down in some kind of a notation. I have books by people like Gregory that came with plastic templates in the back to help you draw the little shapes on paper, the lozenges and clouds and whatnot that represented the different notations for object orientation. And you need to understand whatever domain it is you're writing in. So my undergraduate work is in chemical engineering. So if I was going to model, as I did, chemical reactors and refineries, you have to understand how a heat exchanger works or how a pump works. That's how you can write good code to model one of those. And if you're going to write something that sells things to people and charges them sales tax, you need to understand the rules of sales tax, not just to write the code, but even to design it. So for example, in some countries, there is just a sales tax rate, period. In many countries, some things are taxable and some are not. And in others, there are different rates for different things. So designing and saying every object will have a sales tax rate might not in fact be the correct design in some countries.
She stops coughing soon.
And probably the biggest lie is that once you've done that, you're good. Going forward, if anything changes, they change the rules for sales tax or whatever, you'll just go to this one place and you'll change it. Sorry about my throat. Now, when I call these lies, right, they're really just simplifications. My granddaughter is 5. She's learning to read. We tell her this is the letter C. It makes a cuss sound. C for Chloe. C for cat. We don't tell her about Pacific Ocean.
Okay, so when you see this word abstraction, just think of word general. The general category. Computer people seem to forget there's other words that mean abstraction, and it usually means a vague idea. To most people's minds, when they see this word abstraction, that means some kind of very complicated, strange, otherworldly art, or it's so hard to understand. Just anytime a computer person says abstraction, it just means the general idea or the general case or the general category. That's all it means. All right.
There's the C's in Pacific Ocean.
So she's saying that once you've generalized a system, you're all set. Well, not really. And I think this is where she gets a little bit of confusion. I do like this talk. I do like this lady. I like her approach to some of this stuff, but it's not object-oriented programming, and it's really kind of strange that she's at a C++ conference or something, and no.
Different sound. And in the same way, like C is for Chloe, and C does make a cuss sound for cat, but you're not a fluent reader of English if you pronounce all C's that way. There are other things going on for abstraction. The truth is, yeah, you do design and find some abstractions. And you do need a way to write it down when you don't have code. And you do need domain knowledge to discover them. But you're not done when you found those.
He's saying you do have to know your field to discover the generalizations, categories in this whatever system that you're working with. That's all that she's talking about here. Just because you can find the abstract ideas, find the general ideas. Like if I have a bank, I have a bank customer, I have loans, I have accounts. Once you get all those things, doesn't mean you know how that works, or that you're done. Or that there's not weird end conditions.
You've just started. You're going to continue finding abstractions for as long as this software exists. And most importantly, you find those abstractions completely differently than the way you find them when you're designing. Then the only way we've ever.
And that's why we have to. That's why I'm at the throwaway development. We're gonna build at least 2, and we're gonna really try to build them. But we're gonna plan on throwing them away because those are the ways. That's how you learn. That's how you. It's called building the prototypes or building. You're just building something, but plan on if you have a time frame involved, you have a time period, and you have as much time as you want to get to the you're trying to get there sooner, not faster. Does that make any sense? So you're trying to get to a product sooner. That's what you want without necessarily faster. I don't know where this faster came in. Maybe people misunderstood the point of like software development. It's not to get to the end goal at the finish line under budget and then perfectly everything to spec that we decided 22 months ago. That's never been a thing, by the way.
Never taught you to find them. So that's what I want to talk about in this talk, is finding missing abstractions in working code. You don't need to understand how chemical reactors work. You don't need to understand how...
For this stuff we're talking about, it's not a domain-specific thing. This is more mechanical and just knowing how the language works, language features.
To run a rental car business, okay? This is not about drawing on a deep domain knowledge. And you don't update the diagrams. You don't have any non-code notation for these missing abstractions.
So I just want to point out to her that she didn't have that either. That's why I did all the code examples. She has some like generalized stuff, but I actually go and show like what she's talking about in actual code here for each one of the things she's going to talk about. So that's what I've gone and done here. You can go follow along. Go to the website. It's in the deedly-do down below, and you can follow along or look at them afterwards. And I'm just going to go through them briefly, but I really, it's intended for you to, I'm not going to walk through them one by one. I'm just intended for you, okay, I've done enough work here that you can go look at this code and say, oh, I see the differences here. And I'm going to touch on each one, but that's the value add I'm bringing.
And you certainly don't check with the business. Hey, listen, we've got orders. We talk a lot about what orders do.
I also want to point out there's things that she didn't see because she's still stuck in this class-oriented programming paradigm, and I've been influenced by the Boop style from Yegor Bugayinko and David West and Alan Kay, which there you can see I've got a whole series on that as well called How to Program from the Ground Up, and I have a whole series that identifies the differences between class-oriented programming and back to object-oriented programming, which is what Alan Kay was talking about, and why those two are very different. And the stuff that she's talking about, this stuff can only scale so far before you start to have the problems that everyone's complaining about. And you're going to have to switch over to a Boop, and you're going to lose some performance. So C++ guys are going to lose their minds. But you can segregate that stuff away. You can have the C++ stuff that has to run really super fast, but the code to coordinate everything and prepare everything, that can be done in a different language in the Boop style.
I've decided to be useful if I had an order item class. Is that okay with you? That is not a phone call you're ever going to have. These abstractions are in the code. You see that in the code that there's a missing abstraction. The code tells you about it. The code screams at you about it, to be fair. And then you put them in the code. Whatever's missing, if there's a missing class, you make a class. Now the abstraction's in the code.
So she's just talking about this code level mechanics stuff, which we're going to walk through, which is important. And it does help you, also helps you rearrange your brain about how to do these other things in a more efficient way that's more scalable.
Most people, if you were to say, hey, who's that person who's coming to speak to us this week? What does she do? They'll say, oh, she's a trainer. And that's fair. I do a lot of teaching. I have a lot of courses on Pluralsight and elsewhere. I want people to write 21st century C++.
This is still 90s style, lady. Sorry. I had to break it to you. All this stuff is all old, and the stuff that you're going about is not actually OOP. It's this class oriented stuff, which is fine, but it's not object oriented. It's not going to get us to the 21st century. It's not going to be the stuff Alan Kay was talking about. For this, we have to give up performance. We have to give a little bit of performance.
I'm going to put a fair amount of time and effort into that because I don't want people to be afraid of C++.
What we get for that is a massive amount. Sorry to keep interrupting, but what we get for the trade-off is a massive amount of scalability.
To write 21st century C++, I'm going to put a fair amount of time and effort into that because I don't want people to be afraid of C++. I mean, like, if you're not careful at parties, I'll start talking about that. That's one of my things, you know. It's just okay if it's a C++ party, but it's less okay if it's like a neighborhood barbecue. And when I'm not getting paid to teach and train, I'll come in as a consultant, and sometimes it's as much a management consultant as it is a C++ consultant. When projects are in big trouble, and especially when people own code they can't maintain.
And that's the number one thing. So the boop, the thing they're talking about the boop all the time, this is the main thing right here. That we get to a point using this COP style where you cannot maintain anymore. There's just too much stuff all tugging on each other. And the number of complexity layers, it just gets overwhelming. So you have to give up a little something, but you gain something else. So
happens more often than you might think. The last person who understood this code is gone. In some cases, I mean, gone. The number of phone calls I've had that has started with telling me that they had someone who understood the code, but he died. This is a real thing. Please do not be that person. Please do not die, and no one else knows how your code works. That's not job security.
That is job security, though. And when you do the cop route, when things get complicated, then people are like, okay, I guess this is what we're gonna do. We're gonna have to do it this way, where everyone thinks super complicated. All right, well, and this is the threat.
And I come in these situations, and I figure out how to make code that they can understand, and how to make code that they can maintain. Sometimes I have to teach them C++ so they can read their own code, but a lot of times I have to fix the code. And what I have to fix about it is generally that it is missing abstractions. That's why they can't understand it. It doesn't make any sense because it's missing abstractions.
Well, I think is it missing abstractions or just missing some code organization? And there's probably other things that's missing.
But it's important to know that the things I'm going to tell you are not just about going into legacy code. Yes, if you go into 30-year-old code, which I've had to do, you will find lots and lots of opportunities to make it better. But with what I'm going to show you, you will catch yourself doing them live. Like literally, you will press enter, and you will look at the screen, and you will realize that there is a missing abstraction in your 30-second-old code. And you will.
So you're just talking about code refactorings here. I don't know about this abstraction thing. I think you're just talking about refactoring.
Provide the missing abstraction. Maybe you'll just add a comment. I really should make this a function, but maybe you'll actually make it a function. Either way, it will be better. So this is not a technique for approaching old code. It's also a technique for watching what you do right in the moment while you're doing it. So I've said missing abstractions a bunch of times. I've said I'm going to give you abstraction patterns. Most people think they know what an abstraction is. They'll say an abstraction is a class.
These computer people. I already told you it's just general category of thing. That's all it is.
No, a class is an abstraction. But many, many things are abstractions.
Right, class can be used to implement the idea of abstraction. It's all about what we're representing here, how we're using these things. You know, what's the semantical use behind it? And computer people are just like, oh, it's just a bag for stuff, just a bag to hold stuff. No, well, if that's what the semantics of your system, well, we're gonna have bags of things holding stuff all over the place, and nothing's gonna mean anything because it's just holding just something to hold things, something. And this is the problems we get into.
But are not classes. Anything with a name. Okay? The minute it can have a name, it is an abstraction. A variable is an abstraction compared to a literal. A class, a function, a file, anything with a name is an abstraction.
When she says literal, means like a raw value, like a 0 or 1. A literal, because she's just throwing these words out like it's like there's only one meaning for them. No, okay. In this context, the literal means it's a raw number.
Abstraction.
Or raw string just sitting out there.
A class, a function, a file, anything with a name is an abstraction. And when we're doing those abstraction lies, we tell you that you do this to avoid repetition and to avoid duplication. And that's true. That is one of the reasons for writing an abstraction. It's probably not the most important. I actually think the most important is the name, but that usually comes along with it. So I live in Canada. In Canada, we work in metric, but we also work in imperial. We have to be bilingual in measurement systems as well as a little bit in languages. And imagine that I bought some code, a couple million lines of code, and all over the place it needs to convert between Fahrenheit and Celsius. I could just plunk the formula in everywhere I needed it. certainly any Canadian is, oh, you're subtracting 32. I see what's happening here. Yeah, we're going to divide by 9. We're going to multiply by 5. I know what's going on. That's Celsius and Fahrenheit. But there's a good chance that once in a while you would mess it up. You make a typo. You subtract 33 instead of 32, that kind of thing. You'd divide by 9 instead of multiplying, that kind of thing. So you make a little function, right? C to F, and another function, F to C. You don't do that because, like with sales tax, what if the rules for converting Fahrenheit to Celsius change? I'll only have to change this one function. We all know they're never going to change. But we're eliminating that repetition of the same formula over and over again, and we're giving it a name so that if somebody reads it who doesn't know why we're subtracting 32, they can tell from the name of the function. We're actually isolating the part of the problem that converts temperature units into a place of its own where everyone else can ignore it.
And it's just regular engineering, just breaking a problem into its different pieces, not copy the formula all over the place. But this is an example that someone would be silly to do. It'd be an obvious place to put a formula, right? But this is the concept. Like, people do this in their code all the time because once you start doing it and you don't know how to manage how to handle the copies everywhere, it's what you do. It's not like the training on this is all that great. So people kind of just figure this stuff out on their own. And that's not the best way. There's a lot of this figuring out on the own. What are these universities for?
And isolation is a very important part of abstraction. If you take all the stuff that's related to sales tax and you put it in a place with a big sales tax sign in front of it, then everybody else can just trust, okay, that's the sales tax stuff. I don't need to understand about that. I can focus on what I came in here to change, which is that I want the total to be blue or what have you. Separating the problem out into different spaces lets different people work on different parts of it. This is just as valuable as avoiding repetition. So there's no need for something to be repeated over and over again for you to choose to put it in abstraction. Of course, the very best abstractions are the ones that you just use instead of writing. So there's a class or a function in the standard library that will give you what you need, or there's a third-party library, right? So I need to look things up in a table. I need to manipulate strings. I need to parse JSON. I need to parse command line options. That's all solved problems. I shouldn't be writing all of that. And
use library, of course.
if I find a not very good implementation of it, I should probably be ripping it out and putting in a good one. The world is now full of examples of people who discovered they were accidentally writing stood rotate. That seems to be a very popular thing for people to not notice
So this is some sort of sorting thing in C++.
they were writing. And it's obviously a better plan to use the standard function than your own. In the book, we say abstraction localizes and minimizes complexity. So rather than having all those minus 32 divided by 9, whatever, smeared all over your millions of lines of code, they're all in one place. Everything else gets simpler. But the trick that you're not expecting is that often when you do that, the overall complexity disappears because this formula for going back and forth between Fahrenheit and Celsius or kilograms and pounds or what have you are not exactly complicated formulas. And yet, by putting them in one place, you didn't just localize the complexity, you actually make it completely disappear. So, when code is missing abstractions, it's your role to provide them. And I'm just telling you, that's going to make the code better. Why? Well, because if you have thousands of lines of code, if you have a class with 50 member variables, I'm not making any of this up, this is all real, how is that different from global mutable state?
I mean, that is global mutable state. I don't care if you put it in a class, you just put static around it. This is the procedural problem we're trying to get away from. When Alan Kay started to talk about OOP, object oriented programming, when they got co-opted with Bjarne with this stuff, and he's calling it OOP just because he's got all the constructs, got all the syntax, but they're not using it because of this. This is because this is a problem in 2023. It tells me that this is still not in the consciousness of people who are training the people about programming. So I'm trying to do my part here.
Like, really, it's not. So you provide the missing abstractions, you provide smaller things, and you get all the benefits that we've always said you'll get from abstractions. The simplest thing to do, I said in abstraction, is anything with a name. If you have a magic number anywhere in your code, make it some kind of a variable. Could be just like some local thing. Could be a member variable of a class if the formula is in a member function of that class. It can be const, sure, it's a constant. It can be const expert, that's also fine. I don't really care how you spell it. What I really care about is that it gets a name.
Right, so she's just talking about here how you don't want to just have raw numbers here like this. You want to give it a value like this, and you can also, I'm going to put this in here so you can say const val pi equals 3.14159.15926, and you should get this out of a standard library, of course. Hey, what's going on? So we could define pi there right here like that, and that's your your constants, and I'll go take that now. There we go. There we go.
Oh, but how am I going to know the name? Here's this big, long, complicated formula. It's got a 23 and a 17 and a 48 in it. Well, chances are there's a comment right before the formula. There pretty much always is. It says, 17 is how many, I don't know, provinces there are in the country or something. And that's where that comes from. The name is almost always right there in the code because someone else has read this formula and said, why do we divide by 23 here? And rather than introduce an abstraction, someone's just added a comment. There's a joke about a consultant being someone who will borrow your watch to tell you what time it is. But if you're walking around with a watch on going, man, I wish I knew what time it was, then you need a consultant who knows how to read watches for you. And I very much borrow people's watches when I look in their code, read their comments, and use that to give a variable a better name. So give your constants a better name, not 0 and 1, like real constants, but don't reinvent the wheel. If you've got 7 in your formula, don't just introduce a constant called days per week. Go off into the chrono header and see if there's something to convert between days and weeks for you already. Something that is already written to handle all the weird edge cases that might appear. You want pi? Okay. Bring in the numbers header and use std numbers pi.
Right. You shouldn't do this. This shouldn't do the define to pi like this. You should bring in the math header. So you should bring in what is it? Math.pi? Math.pi? Yeah. So it really should be that one from the standard library. Let's keep going.
Or square root of 2 or whatever other number with a name you want is probably in that header. That's more expressive to other people than your super cool arctan of -1 or whatever related formula that you've come up with to calculate pi by. We'll start with a really simple one. I see this sort of thing all the time in old code. You've got report. I chose report because pretty much every old system does reports. It used to print them, now it emails them, whatever, okay? And they used to just have the report. And then they're like, oh, actually, the reports are going to be a little bit different for some people than for others. So they add like a report type member variable to the report class, which is fine. And they decide to use these macros for the report type names.
Now, this is very common in C and C++ for this to be at compile time. They would define these constants, and this is how they would do it. It was so nuts. I mean, it worked, but it became a problem, and we'll get into why.
Common prefix because, of course, macros are not in their namespaced in any way. So RT is going to be the name for all of these ones. And then having apparently...
So she's talking about macros, and these get expanded out at compile time, and they're actually just replacing, basically does a search replace. So anywhere you use the word RTB, it would replace it with 1000 before it actually compiled the code. That's what she's talking about.
Just had this, well, we used up 2 letters. We can't be going crazy. We'll just use 1 or 2 from now on. So RTB, RTC, RTBC, and so on. And you know how many mistakes you can make? I mean,
and then back in the day, this was because characters, every little piece of character memory we counted. And if you have a big program, this becomes a problem.
This is 3. But that's because we're on a slide. Like in life, there's 107 or maybe 700. There's just like so many.
Right.
And you need to copy and paste. And there are 3 different things you need to change: the name, the numerical value, and the comment. Ask me how often people successfully change all 3. But then, what order do you put them in? Do you keep them in numerical order? Do you keep them in alphabetical order? How do you know if I'm just going to add another one and I want to give it the value 2006? Has anyone already used 2006? There's a delightful series of bugs when 2 of these have the same numerical value.
And that was very common. If you didn't know the numbering system the previous person was using, because usually there wasn't any comments or there was no way to know what the numbering system was. It could easily clash, easily. And if there was something else, someplace else that was using this that unrelated that you didn't know about, oh yeah, it gets real fun.
Right, because then your switches and whatnot are going into the wrong switch and you can't figure out why. There's a ton of mistakes waiting for you here. Just use an enum. Okay, now the numbers will be assigned by the compiler, so they're going.
Right, so he's talking about here, we're just using enum, and this is the example here. So instead of using this RTB thing, it's now using these enums, right? Just easier to read, and you don't have to keep numbers and the things. The enum is doing all that. You don't have to keep the numbers now.
Going to be in the right order, and you can use all 26 letters of the alphabet should you desire. Now, this is an old school unscoped enum, which means that the names have to be unique. So I might still need to have some kind of a prefix on them, like RT basic and so forth. I normally would prefer you use an enum class, a scoped enum.
That was like a C++ limitation. You'd have to put another thing. You'd have to do the same thing, like add report on the front of it. Report type basic, because there's one namespace for all the enums. Silly.
But these are very often in a switch. And you can't switch on a enum class without casting it back to an int first. So for that particular...
I mean, there was a limitation at one time that they've taken that out, but it doesn't matter. These are the kinds of things people did. These are the reason why people still think that. these things keep going because they still think that the language is like that, even though it's changed. You can't keep track of all the changes. It's like too much.
In case you might want to stick with the old school names, in which case you might need to put prefixes on them so that you can tell them apart from the other kinds of basics. I meet a lot of this kind of stuff. It's super common. And the person who died, would have been able to look over this and go, what? No, you have one of these trues and one of these falses flipped. But all the new people are like, I don't know the difference between these calls. At a first glance, do you notice that two are these?
Okay, I had to get that all set up here. All right, so she's talking about this stuff here. Now, in this IDE in Kotlin, it's actually giving you hints. It's actually the IDE is like giving you the hints about these names up here. But and I think that's on by default now, and it didn't used to be. And it would just be these strings of true and false, true, false, true, false, true, false, true. Like, you have no idea what these things are. I mean, if you have one, maybe, but you have a string of them like that. And there's so many things like this. Oh my God. So let her get into it. Yeah, let her kick. Okay.
What? No, you have one of these trues and one of these falses flipped. But all the new people are like, I don't know the difference between these calls. At a first glance, do you notice that two of these are true in each call? It's generally a bad idea to have consecutive parameters of the same type, but it really wouldn't be better if there was one int in the middle of all of this, right? It's the sheer number of parameters that's starting to make it horrible.
So what I've done here, because I can't even stand looking at this stuff, is I've actually broken these things up into the individual lines. But you'd be surprised how many people have them just straight off the edge of the lines. I'm like, guys, we have lots of line count. We can scroll. It's okay to put these on separate lines. They put them all out like this. Oh, let's keep going here. Keep going.
And I find it especially frustrating if, let's say, the default is false. I really just want to turn on 2 of the 7 options, but I have to specify those other 5 falses because defaults can only be at the end.
Yeah, so she's talking about like how about this thing, this update person idea. So you create an object, or no, here's a function, right? You takes in a person, and this has got a bunch of booleans about which thing you want to update, right? If you want to update this person, whatever here, we could create this person here. Or do you want to update the name? No. Oh, we update the name. Okay, yes, but we don't want to update the age. So this is the kind of stuff that people would do in C++. And here's the update data at the end here. And, it would go through, and here it says update true. This is the kind of stuff that they would do in C++. I swear it was just like, what? But there's reasons why. There's reasons why they did it like this. Okay, so here's a little bit better way. So you have this just have the class, the update again, still the update. But what did I change here? Oh yeah, so we have a class now, a data class that represents. So you all we have is instead of all these parameters now, we've got just the person update object with all the things in it. And she's saying this might be better. I don't know. And then here's the update person here when you pass in the object and just the person. So you have to build this person update object. Okay, I guess that's sort of better. But in Kotlin, of course, they saw this as the problem, and you still have this. They still want to do this update person thing like this. Okay, that's not really. I mean, you can just do name parameters, right? And you can just say whether you want to update each one in the name parameters like that too. But okay, that's sort of a little bit better. But what you want to do is you want to do this person copy. So person is a data class, and in Kotlin it has a whole bunch of extra features, including this .1 .copy that will .print .equals. So there's a bunch of stuff that says, oh, you're using this as data. Okay, I mean, you can make it into any, you can add methods onto it, but it's going to add a bunch of stuff that's just for like using this as a data class. So we're saying we're just using this as a bag of data. We're not going to put anything in it specific, but we don't want to print. We want to copy and things like that. So, and with Kotlin, you say person copy, and you just give it the name of the parameter, which one of these, the property, which one of these properties you want to copy, and you just give it the value, and that's it. They've skipped all that stuff. They skipped all this crazy builder pattern stuff. So that's just down to one line. And if you use the data class, it's down to one line, and you just tell it which one you want to change, and it changes it.
So I've done this many times, and it helps enormously with readability. You just make a struct. And in this case, I'm taking advantage of default values. I'm going to make them all false, so now I only need to set the ones that are going to be true. And I change the function to take an instance of this struct. It's just a struct. There's no getters, there's no setters, there's no encapsulation. And the code is pretty mechanical to change. People say, well, where'd you get those names from? Well, those will be the names of the parameters inside the function, right? Because the reason is, nobody sits down in that we teach abstraction lies pre-designed stuff and says, we should totes have a function that takes 7 bools. Like, that was not done on purpose, right? It didn't used to take anything. And then it needed 1. We need a special case for Europe. So we pass in this bool of whether it's Europe or not. And then it needed another one. The year-end version is special. Okay, so it adds another one. What if the notices were already sent and we're just updating again, but we don't want to do the notices again? Okay, so they just keep adding. So generally, they have pretty good names. And you just take the names of the parameters and make them the names of the elements of the struct. And then you mechanically, anywhere in the code for this update function where it said if Europe, something or another, you go if opt.Europe, and the rest of the code is unchanged. It's pretty simple to do. Then calling it looks like this. I'll set up an update options object, set just the things that I want to mark as true, because the rest all default to false, and call update. Europe prelim is a pretty crummy name. It's really just telling you which 2 flags I turned on. If this was a real example, I could probably give it a better name. There's probably a particular circumstance that corresponds to its preliminary results for Europe. And it's easy to tell the difference between this one, where I'm setting 2 different things to true. But it's not just about parameter lists that are hard to remember, like 7 bools in a row. Sometimes people are very confidently sure that they know what your parameters mean, and they're wrong. So the classic example of this genre is drawrect. Think for a minute about what these integers mean. Probably half of you thought there was x1, y1, x2, y2, and probably half of you thought it was x, y, width, height, or maybe height, width, right? Could go many different ways. The problem is a missing abstraction. If my draw rectangle takes 2 points, now you know what those mean. When you make these structs, they might not end up as structs. So I've got some function that takes 3 strings and a float. And I decide, no, you know what? That's actually some kind of an abstraction. It's not going to be an employee or a purchase order, because those kinds of abstractions got figured out back during design. But maybe it's an employment contract. Maybe it's an order item.
Hold on, let me see where we're at here. Where are we on this one? Let's see. I can't remember which one's wrong.
Something like that. This function that takes a t, whatever t is, maybe this should be a member function of the t class. Maybe it should. And after inventing the struct, there's nothing wrong with stopping and asking yourself that. Is this really a free
struct? Is the C thing for class the same thing? It's just the same thing as a class, except you can't have any methods. It's just data
function. Or is it better served to be a member function of the class you just invented? Now, you know, structs can have member functions. You know that. But most of us, once we add a member function to something, we start thinking about canonical classes. And we're like, oh, the member variable should be private. I need gets. I need sets. I'm going to need special member functions. How many constructors do I need? Oh, rule of 3, rule of 5. Like, don't rush off to do that. This code was working, right? When these were just local variables, everything was fine. The reason we have private member variables is to protect invariance.
I really don't like her terminology here about this invariant stuff. I think it's just kind of off topic. It's sort of like, I really don't know what she's talking about here.
Some classes have invariance. So if I write a bank account class and I have a transaction log and I have a balance, if you were to start at 0 and add and subtract every transaction in the history of the account, you should end up with the same number as what is in the balance. That is the invariant of the bank account class.
Okay, so it's just a rule, a law of how it works. Okay.
And that's why you don't have a set balance method. You have deposit, which increases the balance and adds a transaction. You have withdraw, which decreases the balance and adds a transaction, and guarantees that outside of those member functions, the invariant always holds.
Okay, sort of.
It is possible the structure you're inventing do hold secret invariants. Like maybe for your points, that X and Y have to be in the same quadrant in the particular universe you're working in which case you might want to actually have set methods that would deal with that. But it's more likely that there's no invariant whatsoever, which means you don't need that kind of encapsulation. You don't need getters and setters. You don't need destructors. You don't need special member functions of any kind.
Yeah, that stuff's, yeah.
It's okay for these to just be...
That's not OOP, by the way. That stuff's like, getters and setters have been deprecated like years ago.
A thing with a name. Don't run off and do design. It is a good idea to look around. I mentioned that this free function taking a t might be a member function of the new t class. It's also possible there's some other local variables that belong in that class and some other functions that take this new type that should be member functions of it. That's fine. Consider that possibility.
Okay, so here it is. Here she's talking about like in C and C++, it was very difficult to have a complex return value. It was like it would be a simple like an int or a float. You can just return one thing or a pointer. So they actually had this idea where they would start passing in. They would pass in an object that they would use then They would fill in the object. They would fill in the return data in this complex object called outparams. So this is just a really odd syntax. He's like, "What is it?" So this is actually not an input parameter. This is an output parameter. It's like, okay, this is a very the standard C++ thing that C++ programmers will bring it right over if they don't know that like there's another way to do this.
I don't like outparams. I think if you've heard me talk before, you're familiar with the fact that I don't like outparams. You want to return something? Return something. It's a pretty simple rule. Oh, but I need to return 3 things. Oh, well, we've only had that capability, for as long as we've had the language, so I can understand you might not have learned that part yet, right? You can return a struct. You can return a pair. You can return a tuple.
For early days, you could not. So this is where people got stuck in that stuff, like thinking that you couldn't do these things. So yeah, it was.
Struct has a name, and its pieces have a name.
And you have to pass a pointer to these values, right? You have to pointer to the struct. So people would have to know about pointers, and they would not realize you could return a pointer to a struct and pass that point. They didn't know they could do that.
All a good thing. You can write your own struct with names. Other people have written a couple of fairly handy things, optional. So if what you need is a Boolean, like this worked or not.
So she's talking about this stuff right here, this result class that is all over the place. So basically it's like, if the value is good, then I'll return the value unless there's an error, right? If there's an error, then I'll indicate the error here. And so basically it returns 2 values at the same time. And if it's one is if it's not an error, it'll be the right value. It'll be the correct, whatever the return value is. And if it is an error, it'll be the error message. That's what this is doing here. It's an optional. It's different. It's really weird. It's an either. It's a monad. It's a functor. It's like, okay, it's like, just call it result. And I just wrote it right there. That's all it is. And there's some extra stuff too that you could do with it, but that's the idea. It's just a structure that returns either the value or the error, or some other thing that you want to, the opposite thing, the thing that went wrong. Okay, so that's what that is.
And then a value, which is only usable if the Boolean is true.
And then she's talking about here. What is it here? Where we draw a tuple or triple, a pair, or a tuple. They call them triples. It's different. It's so different. And it's like, okay, it's just 3 values. A double, a double, a double, right? So it's gonna return 3 values, like a struct of a double, double, double. That could be any doubles. That's all this is doing. Ooh, it's a pair. You mean array of 2 items? A triple, you mean an array of 3 items? This stuff.
That's what optional does for you. Expected. Can I say stood expected yet? I'm getting nods from the people who are nod qualified. I've been using expected for quite a while. Cybrand has a great one.
So she's just still going on about this thing. That's just 2 values. You're returning 2 values. Ooh.
But we do now have can expect stood expected, which is 2 thingies, and it knows which of them is legit. One's what you're expecting to calculate, some object or an integer, whatever, and the other is an error type. And so then if everything works, you get what you expect back in the value, and if it didn't work, you get an error in the error. That work's been done. Take advantage of that. Don't roll your own thing where you have a bunch of pointers and you return a bool, and then depending on the bool, you look at different ones of the pointers. It's much more readable for everyone if you use things that people can look up on CPP reference. That's one of the things I like about optional and expected. That plus they have some nice bool conversions that let you say if result, and it does what you think it should do. The other thing I see, I don't have to understand the code. I don't have to know anything about running nuclear reactors. Just need to be able to pattern match. Is this kind of thing. Now, the older the code, the more likely it is that people declare a bunch of stuff at the beginning without initializing it, and they're all clumped up together like this. But you can also spot it when they're spread out a little further. They just don't fit on slides as well.
Okay, let me see if I got this example. Okay, yeah, she's just talking about, people will put okay, stop. What is it doing? Why is it doing all that? I didn't do anything. I didn't touch it. It's doing stuff on its own. Okay, okay, yeah, so people will put these things. They would add this employee prefix to everything, and they would have a bunch of variables like that. And those are all the employee stuff. It's like, well, those really should be put into something like this. That is all she's saying there.
They all start with the same 3 letters. That I see all the time. 2, 3, 4 letters. It's because they're all parts of the same thing. In this particular case, they're all parts of an employee. That is the employee first name, the employee last name, the employee title, and the employee salary. And if you do nothing more than just gather them up into a single struct, and then declare an instance of it, then you can sort of mechanically put a dot between the EMP and the first name, the EMP and the last name, and you're good to go. Often this does lead you off onto other things, but just seeing the names all starting with the same letters, it tells you that these are in fact one thing, and you can take advantage of that and put that information in the code. Take a look at these declarations. Again, in real life, they might be slightly more spread out. Without even looking at the variable names, you see something here, right? There's two clumps. There's two.
Okay, so sorry about that. I got a little. Okay.
You see something here, right? There's two clumps. There's two thingies. And when you look at them more closely, the first clump, start value, end value, number of points, average, tolerance, this is some kind of statistical something involving values. And the second clump, that's a latitude, a longitude, an altitude, visible, secure, this about some sort of physical location. They're clearly very different. I don't need domain knowledge though. All I really need is that blank line. I call this a load-bearing blank line.
Right here.
Right? It's very clearly.
Right, you could just tell right here. This is separating these two things, and this happens all the time. And you'll just do it naturally, of course. Everyone does it naturally, but this means that these really should be two. They're grouped together like that, and they really should be a class around it.
Demonstrating these are two things. Okay? You can create two classes or two structs now to hold these thingies. But look a little closer. Look at the first line of each clump. How long have we been told not to declare two variables on the same line with a comma? Right? And if there's a pointer involved, it confuses people.
Okay, so this is
but we still generally are told don't.
So this was a C++C thing. It might have been in Java. I don't know. I can't remember. I haven't been using Java for a few years. I can't remember. It doesn't matter. Would you put two variables on a line like that just to save typing? It's caused so many problems. Oh my God! That just that simple thing like that.
Right? And if there's a pointer involved, it confuses people. There's no pointer, but we still generally are told don't do this. But whoever wrote this code did this. Maybe didn't even notice that they did it. That's what I love about this. Sometimes I talk to the person who wrote it, and I say, you knew they were a thing. Start val and end val, latitude and longitude. You knew they were a single thing. You declared them on a single line, and the person says, huh, I guess I did. Right? You're sending messages to the future, but also to yourself right now. When you want to declare start val and end val on a single line like that, it's because that pairing is really one thing. Listen to yourself. Make it one thing. Now, a big part of refactoring, oh my goodness, the big functions I've walked up to 100 lines of code. Please, you are like little baby. I used to routinely have phone calls where the person would say, so if you go to line 5,896 in such a file, you'll see, and that would be like in the middle of a case statement that was itself hundreds of lines long, which was in a switch statement, which was thousands of lines long, and the file was 10 or 15,000 lines.
So this is just the standard procedural stuff that happens in procedural languages. It's pretty normal, actually. It's kind of how you build them. It's how we're taught to build them. We're not really taught to break these things up. And also, when we try to ask for time to refactor these things, we're often gotten pushback. Just make it work this week because we're about to go under. Just make it work this week. And guess what happens after week 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 after week? You get 15,000 lines of code in one flat file. Oh, it's a joy to work with, by the way.
And yeah, we had to do a lot of refactoring. But how do you do that? How do you know where in these thousands of lines of code to grab this 106 lines and make them a function? Blank lines. Load-bearing blank lines. There's also comments, right? The number of people who are like, pick out all the rush orders, process the orders. Like, whoa, you're so close.
Here.
So close.
Here.
Your tool will do this for you. Do not ever try to do this by hand. And you know the best part of any refactoring tool is the undo button.
Oh, she's just talking about refactoring. No, the best part of any refactoring system is having tests. So when you change something, you know you didn't break something somewhere else. Guess what? These C++ programs don't have a lot of tests because it was written in a time and age when testing wasn't a thing. It was just important to get it running. And Charlie knows how to fix it. It'll be in next week. So you got to use the refactoring tools if you're going to go into this kind of thing. But the most important thing is to having tests set up. And if you don't have tests set up for it, forget about refactoring efficiently. Doesn't matter what the tools are.
Okay, so you select 107 lines, maybe separated by some convenient blank lines. You say extract function. And your tool says, sure, it's going to take 11 parameters, 4 of which are out params. Undo. That was not the correct refactoring. You want to absolutely minimize the information flow into and out of this function you've just invented.
So she's talking about when you go back and start to refactor and do the refactoring stuff, which I'm not going to do in this exercise. I'm going to show you what happens after the refactoring, where you're breaking these things into functions. Yeah, you have to be careful about what variables you take with you because they're not all going to be needed, and the refactoring tool doesn't know what we're just going to assume that you know which variables are going to be needed. And sometimes it can be pretty clever about it, but sometimes it's just no.
Yes, you need to be able to give it a name. But ideally, it would take 1, 2, 3 parameters and would return a value.
Right.
And depending on where you choose to select the lines, that's what's going to grow that. So when you see that it has 3 out params, take a look at what are the variables that are in that block of code that are still used afterwards and figure out maybe if I should select less lines at the top or less lines at the bottom or something so that it doesn't work that way. Let me take a couple tries. But again, without any knowledge of the domain, what is the grouping of these hundreds of lines of code that minimizes the parameters that are going into and out of that new function? And then you'll need to name it. But once you see the parameters and the return type, that often will be all you need to understand it. Oh, I'm adding up all of the totals. Okay. Now, if I have a 5,000 line file and every 100-ish lines of code becomes a function, I then have a function that is 50 function calls in a row. Perhaps that itself could do with a little compression. Here's where you need some judgment. Okay? Maybe you could turn it into 5-ish functions, each of which calls 10-ish functions. Don't ever do this numerically or mechanically. One of my first jobs programming.
She means just don't do it. Oh, we're just gonna push all these things around. No, you have to be smart about it and be semantic about it. Like here, you can see this. This has been really nicely set up. It's usually not gonna be like this, right? We've got the import data here, and it's data imported, and it's gonna make sense. Okay, import data here, prepare calculations here, It kind of makes sense, right? And you have to use your brain. And the thing about it is like coming in after the fact, it may be better just to start over and take the learnings here and put it into a new system. Oh, but it's millions of lines. I know, but it may be easier.
I was an undergraduate student, and at the University of Waterloo, we do co-op. So we're put out into industry and do real jobs. And I was working in industry in Fortran, and the person there who was in charge of us was, to my mind, very old and experienced. I mean, she probably was 24, 25 years old, and she knew everything.
Young person joke. Got it.
And
hey, when I was 7 years old, I was already programming computers, lady. By the time I was 13, I was already making money building software for people. By 18, I had my software in Kmart for IBM PC, doing crap simulations. I was 18 years old. So by the time I was 24, guess what? I was already starting my own company, lady. So yeah, young people do know a lot of things. Okay.
One of her rules was no function could be more than 20 lines long. So if you wrote a 21-line function, we didn't know any better, and it seems that she didn't know any better. The first 20 lines would be called like calc 1, and the last line would be called like calc 2, and then you just call calc 1 followed by calc 2. Please don't ever do that. So when I say like 5 and 10, I don't mean any of these numbers precisely. But would it make sense to take your 50 function calls and clump them up a bit? Yes, if you can give the clumps names, if that gives value. If this 9 function calls are all about permission, and these 12 down here are all about, I don't know, sending emails or something, then you can give them names, then that's a good thing to do. If it's just going to add confusion, if it's just going to add another level of indirection, then don't do it. Just give me the...
Right. You don't want the ping pong. Ping, 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 ping. Just because we can split it up to 100 different files doesn't mean we really should. I mean, we got these collapse tools here. You can hide a lot of stuff. You can hide sections of code. You can hide, like, you can really, it really is pretty good about it. Like, especially if you go down here and, what is it? So this broke it up into these series of functions, right? And this one down here, this import data, I have one that calls another one. Where did I put that? Import blah, setup configuration. Okay. Anyway, keep going.
The 50 function calls. I think it's unlikely that none of them have any commonality, but don't invent abstraction that doesn't have a name, that doesn't have a purpose, that doesn't add clarity.
Right. I've worked with a lot of code bases that were just doing this by rote, and you were just hopping around. You just spent a lot of time hopping around from file to file. Because someone just went in there one day and was like, we have to abstract this. And just like every file is like 3 lines. I'm like, is this really got to be 3 lines? Or an interface with 1 line and it's only used in one other place. Can we just put that at the top of the file? Why not? If it's only used in that one place, I'm only be using the navigation tools inside the IDE anyway. I'm not going to be navigating by visual. We got so much pushback on that kind of idea, so just get ready for that.
Remember, we're trying to reduce repetition, we're trying to reduce duplication, we're also trying to isolate parts of the problem. I saw this on Twitter recently. Someone was complaining about comments at the end of a long series of nested things that ended with closed braces. So you said while, somewhere inside the while there's an if, it's like a couple hundred lines in the if, then inside one, maybe the if, maybe the else, there's like a for loop, and it gets to the point where somebody feels the need to label the closed braces. This is the end of the for, this is the end of the if, this is the end of the while. And the original assertion on Twitter was that they were pointless, they were just noise, they should be deleted, and my statement was, no. It's telling you it's too long and too nested. Don't just delete them, use them.
Yeah.
Because very often, when I used to do this, I would just copy the original if and put that in the comment. But kids these days are way more hardworking than that. They paraphrase the condition. They're telling you the name of the function that you're going to use to put inside where these braces were.
Right.
Okay? It's got a name. We're processing each outstanding item, or this is what you do when you're over limit. Fantastic. Does the if go in the function, or is it if function? That's going to be a judgment call on your part. A couple different ways to do it. Here's a situation, using reports as an example again, and I apologize for the font size, but I'll read it to you. For every R in reports, and then there's a closed brace way down at the bottom of the screen. If, we'll call R's header needed, R points to do header. So imagine this didn't used to say do header, it used to be 20 lines of code. Then we do some little local calculations about how many lines are going to be in the report, and then while for each line. Well, again, R points to new line was maybe 100 lines of code. And that's why we needed to have comments on the closed brace of that while. And then we have another if about if you need a footer.
Okay, so I split that up a little bit into two sections. So here's that class report. This is the before example. This is very procedural. Very procedural mixed with object-oriented kind of code. This is just generating a couple sample reports data. And then it's got the before. It's just for each of the reports, it goes in here, it does the header. This is very procedural style. And then does the line, and then does the footer. Okay, so this looks object oriented because you've got methods in here, but it's just operating on this data. This is very COP style. It feels like you're doing object oriented because you got these classes, and you're calling the methods in the class, but this is still very procedural with the clothing of class or the clothing of OOP.
So this is a simple way to do it. Keep your ifs, keep your whiles, keep all your nesting. But just take whatever was between the braces and make it a function. Because of the scoping of braces, the chances are you'll have really limited parameter action when you take these out into functions. These are member functions. They're only working with member variables. It's fine. So this isn't wrong, but you might prefer to do this. So what this says is, you know what? I don't know who this code is that's looping through all the reports. But why does it need to know whether a report needs a header or not? Why is that the business of this calling code? When you think about encapsulation and abstraction and keeping like with like, sure, reports know whether they need headers or not. But why does external code need to say, hey, do you need a header? In that case, do your header. Maybe we better just say, do your header. And some reports would be, I'm good. Right? They don't need a header, they just return. That works. Why does the external code need to know how many lines there are in the body of the report? Just do your body. I mean, I'm making these functions up. So I can make them up however I like. So these are both.
So you can see here how this report says do header, right? And each one of these reports will define whether they would need the header, whether the footer is needed. Very data oriented style. And then it just goes through each one of the reports and then just calls each one of the things up here. And then, because the do body, now they've keeping this do line private. Ooh. Okay, but still, this is very procedural approach. And this is a little bit more OOP style, where it actually just calls this generate, where it does not calling these external functions, header, body, blah, blah, blah. It just calls generate. This is more OOP style, where it'll check to see if it needs to do the header inside the class. This is getting more towards the boop land. And we'll get into that a little bit more about what the boop land looks like.
Both right. Some people, when they see that one, they go, why does the calling code need to know there is a header, then there's the body, then there's a footer? Why don't we just have do report? And I'm not going to argue. That's what happens when you start putting missing abstractions in. As the code gets simpler and you can understand it, then you can say things like, I got business logic in the wrong place. The logic that says a report starts with a header, then there's a body, then there's a footer, that's report talk. That belongs inside report. Why does some code that's not in report knowing that? And your instructions get better. It's very common to find, especially in older code, but it happens in newer code too, classes that are very similar but only similar, right? And going through and bringing inheritance into play can make a real difference here. Now, this doesn't have to mean polymorphism and indirection and virtual functions.
Oof. Bleh. She's just talking about, well, this is polymorphism. She's about to go into polymorphism. So I'm surprised that she's an instructor and an author and been in the business this long. This is polymorphism. What she's about to talk about is a kind of style of polymorphism. But what she's trying to do here is to she's doing another thing. So that's why she's trying to like contrast with this other thing. So she's talking about how in procedural code, you will often have two different functions that are doing almost exactly the same thing. And in fact, they probably are doing the same thing, except one might be doing something a little extra. But in general, it's just all under one umbrella. And this happens a lot where you have these like just two functions that do one. So what she's trying to say is, hey, I want to be able to combine these somehow. How do we do that?
This can be your common or garden implementation inheritance. You're already using what John Land.
And this is a bad idea. I just want to say this out. This is very COP style. This was actually not the purpose of the C++. This thing was not meant for this, what they're using, but people got it in their brain that this would be a real neat way to do reuse. And it got everybody into a lot of trouble. So I just want to say at the outset, this is very fragile. This will break. If you have to do it, I understand. But realize you just did a deal with the devil when doing this kind of stuff, because this may work with this shallow hierarchy of 2 or 3 levels deep. But if it starts to go like 4 levels deep, 5 levels deep, 6 levels deep, you're not gonna know what's going on anymore. And you should really think back and think about what you're doing with your design.
Lamb calls editor inheritance. Just copy, paste. The problem with editor inheritance is you don't necessarily edit the same for the history of time.
Right. So what she's saying here is like, okay, let's say this sum now has to take into consideration some new gravity constant in the universe. If you have to go change the sum here, and you have to change it here, and this add 3 because it's doing the same kind of operation. So all the places in the code that has to have that change for the new gravity constant they discovered that changes addition, you got to go change all the stuff now. And there could be hundreds of thousands of these things all over the place. And that's what she's talking about.
Right? So imagine that you have like an old system that sent faxes, and there's a class called fax. And roughly 20 years ago, somebody also wanted this thing to be able to send emails, so they made a class called email using editor inheritance. They copied fax.h and fax.cpp to email.h and email.cpp, and then went through effectively with a crayon, crossing out fax and writing an email. And then they made a few changes because faxes go to phone numbers, but emails go to addresses. Maybe emails can be CC'd, that kind of thing. Made a few changes. And then over time, these two classes have been living in parallel. Maybe there's not 2 now, maybe there's 7, right? Because maybe in addition to faxes and emails, you can also send texts and WhatsApps and whatever else. And it's starting to bother people when you need to make a change, that you need to make that same change in 7 places. So if you put all the commonality in a base class and then have each of the derived classes just only override what's different for them, maybe some of the times when you need to make changes, you only need to make it in the one place in the base class instead of the 7 different places in these what are now derived classes, but used to be independent, just similar classes. This can be a wonderful way to fix mystery bugs. It can also be a way to get the business very mad at you. And you need to know this is one of the few times when you need to check with the business. Imagine that you can export as XML and as JSON. And you discover the XML exports include the sales tax, and the JSON reports do not. Feels like a bug, right?
She's actually talking about the big problem when you go down this road with this approach. And this will become an issue. But what she's talking about here, where you've got somebody, you've made a class, you have an intention for it, and you've allowed this inheritance thing to happen in your organization, in your code base. So somebody comes along and goes, oh, I can just use that thing and piggyback on that. That's never going to change, right? Oh, but I was about to change that to this other thing, but you can't now because Jim over in the other department is now using that implementation of that class, and now you're stuck because Jim's got his stuff running somewhere that's super important and can't change this now. That's the problem.
The XML exports include the sales tax, and the JSON reports do not. Feels like a bug, right? You're going to be a hero. You're going to fix the bug. You're going to get a phone call. It's pretty common to hear, oh yeah, We had a new customer, and they wanted it in JSON, but they also wanted the sales tax included. So we just have the JSON export include the sales tax for them. And the old customers, they didn't want the sales tax. They're still just using the XML report. As common as dirt. What appears to be a simple format difference is actually a business rule difference.
Right. And that's the issue. It's the business rule differences. And the thing about this is we don't know going in what all the business rules are. And the business people don't even know what the business rules are because they're not speaking the language of the procedural oriented universe. We have to know everything up front in order to have a system that'll take all of it in. and we never know all the details up front. It's way more complicated than it ever seems at the first. And we don't have a way of dealing with the complexity of how do we change this thing to work with this in this way when we never extend it. Well, just make it work by Tuesday because we're about to go to business.
The PDF reports have subtotals and the HTML reports don't because they're for different external or internal customers. So when you find this similar stuff, you bring it together and you're going to make everything consistent, you need to phone someone or email someone or Slack someone or Discord.
Oh, you're going to call the people of your library you've just published on the GitHub? Is that what you're saying, lady? Is this 1963? I can just call the people on the internet? Just give them a phone call. Hey, Sally. So, by the way, I'm changing this class now. So if you're using it, you are using it, okay, we're going to have to figure out a different way to do it now.
Record someone or whatever.
Okay, I'm being mean. She's a sweet lady. I appreciate she's giving me a little platform to do my thing here, but still.
Is it deliberate that they're inconsistent in this way? And you may have to encode that. And then, harking back to my naming talk, you might want to change the names, right? The difference between these two exports is not just that one's XML and one's JSON, but that one has sales tax and one doesn't. You can put that in their names. They can be called like XML with sales tax and JSON without sales tax. And now people will understand this is a deliberate choice.
Okay, so she's saying that you would create this adder, a base class adder, and then you'd have a fancy adder that would extend that would basically call that thing, and then you have this other simple adder that would still call the same adder here, except it would use an alternate parameter here, right? And this is okay for small projects, like I said here. So and then I give a little advice right here. I did a whole other video about why this is a bad idea and why it will get you in trouble. And if it's not obvious from this example, I mean, just imagine adding 15 things and it's changing one of these things along the way. This is goofy. All right, so I mean, it's okay, but you have to be super careful with this because as soon as you allow this to happen, it causes a whole host of other problems that just makes your code base super hard to change. Now, it looks very object oriented. You're using base classes. You're using the derived classes. You know, you're doing all kinds of things, right? I don't think I need to make this one open, do I? No. Yeah, I have to make that open because this one, I'm doing something else with it. Okay. Let's see here. Hold on. Come on. Stop. Why I want to pause. Recording, window, help. My keyboard thing wasn't. All right, I just made that. I didn't need to have that be open. I wasn't driving these again. I just need to make this one open. And then this was going to be a different. The signature is different here, so that's why it's not overriding this add here. It's actually a different signature. So simple adder has a different signature here, because there's only adding 2 items. So that's what's going on there. And this is a really class oriented style. And then we have the boop style. Let me make sure I'm recording. Okay, so the boop style is very different looking. It's a different way of thinking about the problem, and it has advantages and disadvantages. Okay, I just want to say that out the front. Okay, so what the boop style does, which is my favorite, is it gives you just an interface. Now in Kotlin, you can have a default implementation for an interface. So we're just we're telling the system that this can, if you implement this interface can sum, it means that you're going to be accepting a function that does all this stuff, right? That can do all these things. All right. So the fancy, so this one also has, it'll give her integer result. So you have this fancy sum is a thing that when you ask for its result will return a sum because it's implementing the can sum interface, and then it says we'll also give an integer result. Okay, and then the simple sum also implements the can sum and has integer result. It implements both these things, right? And the way you call it is very different. Like, it looks the same, looks very similar, but you're actually making a simple sum object. You're making an item that represents a simple sum, and then you also have another object that represents a fancy sum. And when you ask it for its result, that's when it does its calculation and gives you the number back. This is the boop style. It is a little strange to look at, especially because it's completely flipped. You flip your noodle around and seeing it in this other way. But this is very scalable and extensible, and yes, it actually uses more memory. It's not as performant. There's more boopity boop things running around. Yes, more direction, but this will scale and allows you to do some very powerful things, and very flexibly, because these things are just they're now not fragile. They're not even the real. You have to like, it's just implementing these interfaces. There's no master adder, right? It just can add and we'll do a summing operation. It'll give a result, right? It'll give a result. It doesn't really know where it comes from and just happens to be using the sum thing. And this interface can sum is the one that's got the group. So this is yet another style that's usually never mentioned, but this is the Jaeger Booga Yinko boop style. So I just want to put that out there. There we go.
How many of you want to do this bit? Want to write a template? Anyone? The front row. Few people in the front row. Yeah, I told you, I'll write a template. Everyone else like, no. Look, I'll do a lot of things, but I'm not going to become one of those template writing people. I get it.
So there's like C++ lore about this because it was a feature that was added to make it so people didn't have to do these kinds of things where they have an integer. So if they have they want to do a list, they have to make an integer list. They have to make a string list, and they're all doing the exact same thing: integer list, adding, except the type is different. Instead of adding numbers, you're adding strings, and you have to write these classes. So the template thing is the C++ way of saying, could we make it so there's a way that we have a list of any type, and I just give it whatever the type is. I can define that as whether it's an integer, whether it's a string. Is there a way we could do that? And that's what templates are. And that's what she's talking about.
I get it, I do. And that's fine. There are other things you could do. If you've got a bunch of very similar functions, you could find some base class of whatever this thing works with and have your function just take that. So I'll have to write it once, and I'll call derived functions, and that's better than having 7 versions of my function. I'll have one that works with something they have in common. That can be the right choice. I can find maybe not something they all are, but something they all have. So think about the STL, which I know is a template, so maybe not a good example, but they don't work with containers, they work with iterators, right? And all the containers.
An iterator is just a thing that lets you say, give me the next one, 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 give me the next one. That's all it is. Do you have any more? Okay, give it to me. You have any more? Give it to me. Okay, give me more? Give it to me. Don't you have any more? No? Okay, I'm done.
Have iterators. So is there something like that you could do instead of having your function take a document, you could take the text that's in the document and work that way? Or I could write a helper function, and all my similar functions could all call the helper function. And those aren't wrong. If you are thinking of doing those things, go ahead. But
very procedural.
Templates are often cleaner. Let me choose the world's simplest example of adding. I have a function called addInt that takes 2 integers and returns an integer. And then I have another function called addColors. I don't know quite what that would mean, but it takes 2 colors and returns a color. And addString returns a string. There's no natural commonality, right? You can't say these are all addables or something and then call their derived plus function. That's just weird, okay?
Right, so what she's talking about here, the problems when you get into implementation inheritance, like the semantics of when you're adding. If you're adding 2 numbers, that makes sense. Okay, you just do the mathematical calculations that we all are familiar with. But if you're adding 2 strings, what does that mean? Does one get added onto the? Do you just add the strings together? Do you add the values of the strings? Do you take the number values of all the characters and then add them together? I mean, you kind of think it's like, okay, you're just going to concat one string down there, but that's not defined anywhere. That's kind of what we came up with to mean when you add plus and plus, but that didn't for a long time. That didn't mean that. That's what the languages we've become accustomed to mean it now, but that for a long time it didn't mean that. If you added 2 strings, you could be doing whatever you want to do. You could be multiplying like a matrix. I mean, there's all kinds of things, right?
And there's also the problem of the return type.
It's the semantics, right? When you're going, it's the semantics when you're coming into a program and you're at line 500 and you're like, what is this thing doing? If you've changed the semantics behind the scenes, you're just causing problems. You're making things harder and making things take longer.
If I make this take something vague and then I call it with 2 strings, then I have to cast whatever I get back because I know it's really a string because I called it with 2 strings. Like, that's kind of getting gross. But if you make a template, it takes 2.
Right. So what she's saying is you could force this int list, the string list to be an int list, right? By changing it, the values here, instead of saying, when you fetch out the number, fetch out this index, you would then say to int, right? You change it to an integer. Okay. So you could kind of, if you wanted to, stretch and use this string list as a number list, but you'd have to do these conversions back and forth, back and forth, back and forth, back and forth. That's not optimal.
T's and returns a T, you're done. It's cleaner. So if you're really tying yourself in knots, and especially if you're tying yourself in knots around return types, consider writing a template. I swear, it does not hurt. I have written templates. It didn't hurt. It's sometimes very, very cool. So
yeah, I've never written a C++ template, but in Kotlin and modern languages, this is all you do, right? There it is. There's your custom type, right? Where it has a string here or an int here, you just put the string or int here. And they call it a generic. It's different than a template. It's so different. If you look it up line, you'll see people these devs get really upset if you say templates are basically generics. They're doing the same thing. No, it's that compile time and you making a whole thing and disappears. It's a totally different thing. It's like, dude, how are we semantically using it? We are semantically using it to have, I don't want to write 3 things. I don't want to write a list for every single type of thing I got. I want to just have a generic thing and do it with that type. Can we do it that? Yeah, and that's how you do it. I don't care about how it's different. It's a compile time. Blah, blah. It's like, who cares? Nobody cares. I'm just writing code. How it gets to the machine, I'm starting to care less and less. I don't care. That's not important. What's important is how can we structure this code so I don't spend 2 weeks trying to change this thing from an int to something else, from a string to an int. I'm not doing that work over and over and over and over and over again. I'm changing 55 different files someplace. That's what we're trying to get away from. No, I got 6% more performance this week. Change it all to stuck point. Can we go back and modify? Does anybody else know how it works? No. You better not fire me. Your company's gonna die.
well, you wouldn't maybe reach for it. I want to encourage you to think about it. And I love this example. This comes from the book. Guy wrote this.
Okay, this is a Windows C++ thing. Implementation detail. I'm skipping it. You can watch it if you want to, but it's totally not a thing anymore, and not used in any modern language. This is all ancient history stuff that's about to go away. Okay.
And all of the Windows stuff is in one file, all of the Linux file.
Keep going.
It comes from realizing that the if is not testing what we're running on to eliminate complexity entirely. There is no complexity when you're done. Once you understand that which keypress.h got included is chosen by your build cert.
Okay.
You have an account type, a report type, a
Now,
I mentioned the idea of a report type, and it's common as dirt. You have an account type, a report type, a document type, a whatever. It's not wrong. Classes have a type member variable all the time. And it lets you, every once in a while, do special things for special kinds of accounts or special kinds of reports. Where it starts to hurt is as everything grows. You go from having 2 types to having 20 types to having 200 types. And you go from having mostly commonality with a little bit of special handling to pretty much all special handling. And that's when the type approach is probably not helping you anymore.
Right. So she's talking about this thing where you have the report type here as an enum. So you're doing the enum thing. That's good. At least you don't have raw numbers somewhere. And then you have the report data here, which is just the data. It has one. Oh, you're doing object oriented. It's getting the type back. Oh, it's just returning the type. It's private though. Okay, this is just a getter. Okay, so this has just got the report data in it, right? This is all very straight procedural, still straight C. Looks very, very OOP, but it's straight C. So here's just generates the raw, the raw data for what we're trying to do here, and then so every single place you have a different type. You have to give it. Switch statement. This is the procedural style. This is why we're like, okay, this is not sustainable. And just imagine if you had 200 of these things all over the place. And you better get them all. And you're not going to know until you get a runtime if you missed one. Because you got the else statement here. That's only going to show up at runtime. There's a problem. Here we go. Keep going.
A switch statement that fits on a screen is useful, better than a bunch of ifs. A switch statement that is 5,000 lines long, not so much. And especially when you find functions where there is no commonality, where the entire thing is just a switch statement. This was the dream, if you will. I'm going to print the header of this report, and this would be no different if it was a member function of report, okay? I'm going to have a bunch of common stuff, 50, 100 lines of commonality at the top, 50, 100 lines of commonality at the bottom, and then this one little switch for just this special stuff, the basic header, the customer header, the big customer header. This is using the same enum that I invented half an hour ago for the defines.
So when she has a switch here, it's the same thing as the when. Same exact thing. This little arrow is the same thing as this case thing. So this is your case over here, and this is, the stuff it does. Okay. Let's see. Did she move on to this next one yet? Let me double check. Print header, report generate. I don't think she's moved on. Oh, wait, hold on. Let's see if she moves on.
Fine. That's like 10 lines.
So this default thing is this else. That's the same.
There's 50 lines above it, 50 lines below it. It's just a little diversion. No big deal. When there's 3 report types. When there's 200 report types, things get kind of yuckier. And especially when there's 200 report types and most of them do the same things as each other. This is a very, very simplified version of stuff I saw in real life. I have a function called footer needed, which you saw being used in the nested fors and whiles. All it is a switch. There's nothing in there besides the switch. And we have these different case statements, but all it can do is return true or false. So if there are 200 report types, and there often are, this means case, 100 case statements in a row, return true. And then case something else in another 100 or so return case statements in a row, and then return false. That's really nasty. Where do you put them? Like when I have to add a new one, what order do I add them in? Because the reason this...
Sorry about that. The wrong button.
Report types. When there's 200 report types, things get kind of yuckier. And especially when there's 200 report types and most of them do the same things as each other. This is a very, very simplified version of stuff I saw in real life.
So this is cert right here.
Function called footer needed.
So this is cert right here. Will crash the machine.
Which you saw being used in the nested for.
It'll cause a seg fault. It cause the program to stop and break, and that's it.
All it is a switch. There's nothing in there besides the switch. And we have these different case statements.
Just because you forgot one of these switch statements somewhere.
But all it can do is return true or false. So if there are 200 report types, and there often are, this means case, 100 case statements in a row, return true. And then case something else in another 100 or so return case statements in a row, and then return false. That's really nasty. Where do you put them? Like when I have to add a new one, what order do I add them in? Are they alphabetical? Are they numerical according to the old numerical defines we aren't using anymore? And maybe someone already added it. That's fun. And you notice we have this assert false now.
Oh yeah, super fun.
Now down at the bottom, which is something that developers put in to protect themselves because there's footer needed, there's header needed, there's 12, 20 different functions. You have to remember to add cases to all of them. So you have the assert so that if you forget, it'll catch it for you. And I know there are now compiler settings to do that for you, but this sample code comes from before that time. This is hard to maintain. It's also almost impossible to read. Like if someone says, I'm not getting a footer on the reports for such a customer, and you go and you look and you see that it's a big customer report, answering a simple question like, are we supposed to have a footer on the big customer report, can be reasonably difficult to do. And I faced this with a real customer. And they had a simple 21-step procedure for adding a new report.
Simple 21 steps. Just 21 steps. It's simple. Come on. Anybody can do it.
And it was simple because I wrote it up for them. What they had before was you phone someone and they walk you through it for several hours.
That's so real.
So it was a huge improvement that I wrote up your 21-step procedure, but we obviously
huge improvement.
Needed to make it simpler than that. And so we had this class report already, and all I did was make the individual specific reports derive from report and added little tiny overrides, like here, footer needed, return false. That's easy to read. If you want to know whether the Europe basic report includes footers or not, pretty easy to go and read this function and say, that looks like a no. Much easier than the old switch approach.
All right, let me see. Okay, let's get this all set up for everybody here. Let's collapse that down. Oh, there's a little bit of lag on my machine. Okay, so here's the base report she's talking about. This is, what is it called? So the big customer, let's just look at this one. So this is what this looks like. This is straight COP, still procedurally kind of put together. These are the similar kinds of things in here. Go look at this on a big, on your own monitor, and go study how this is put together. This is what she's talking about here. This is her improvement, and I mean, it is an improvement. It is an improvement, and you can see how everything is put together here. So we create the sales reports right here. It's just list the sales report, same as the other ones. And this one, creates a basic report, customer report, big customer reports. This is all the reports you need to run. And it goes reports, and then it says report generate, right? So right here, it goes up here. It says is report needed, and then so it has these overrides, right, for the do headers, right? Not for do header, but for is header needed, right? So that's an abstract function. So each one of these things is going to implement this function is going to override these different functions here. I don't know why it doesn't show it here, but this is the one. Oh yeah, that's right, because you have to do this thing. This is showing you which one's being overridden. Like is header needed is overriding that one. So these things are being implemented, even though it's being called from in here. It looks like it's calling in here. It'll actually call out to the overridden one first. So that's a very clever way of doing all this stuff. So you don't have these all in 200 places, just in one place. So you've flipped it around. Instead of it being driven by the data, it's like you're flipping it on the other side by using this abstract class, base class approach. Now this is somewhat scalable. Because these things are flat hierarchies. But as far as if you start extending these reports, if you make these open and make these start to get, you're gonna get problems.
And two ways you can come up with this. One is, if it's always true, if all reports have footers except for the 3 weirdos, then you can have a implementation in the base class that returns true, and only override it for the 3 weirdos, which will make it really obvious for people who are trying to answer the question. Or if you're worried you'll forget, you can make it pure virtual in the base class, and then the compiler will tell you that you forgot to implement the pure virtual function in the derive class. Either way, much simpler.
Right, this pure virtual. This is what she's talking about. This abstract. These have to be overridden here. And you could, I think, if I made this an interface, I could put a default. I could put a default return true. And then make this one interface as well. So something like that. I'm not gonna do it right live, but that's the idea she's talking about.
Simpler than putting assert falses in the defaults of switches. And I have to tell you, I did that in real life, and it worked beautifully. And it took the effort to add new reports down by much less than half. It was much quicker afterwards, and it made a difference because they charged customers for adding reports. So it let them either make more profit or charge less, depending on how you want to look at it.
Made more money. Made more money. They didn't tell them. They just reduced their technical debt by doing this little trick by a factor of 10. They didn't tell their customers that. You can't be lady. They're going to pay for your consulting fee somehow.
Sometimes when I insist on good names for things, the truth comes out that the reason something doesn't have a good name is because it's not really a good sized abstraction. Functions that are called update and
before we go on to that, I want to show you the boop style. So the boop style of doing this, you're gonna have to look at it. I'm not gonna explain all the details. You're gonna have to look at how it's put together, and the only way to look, is to study the source code. Unfortunately, I can only explain so much. You're gonna have to go look at it and have the epiphany that is required when you see oh, that's what they're doing. Wow. Okay, so report generate here. So it looks very similar from the top, but it's just these interfaces, right? So it's can I generate stuff? Can I make a header? Can I do a line? Can I do a footer? And then here's your base class, and it has implemented the generate, right, and the do line. And then you have this basic report, which it's just gonna take this base report, and it's only using these 2 things, and then it's can generate and can do line, and then it adds the can do header and can do footer, and it's all it's all statically inside. It's not statically. It's all enclosed inside this object. So it flips it around, but this is the boop style. So there's no more inheritance except with the just this base class, and everything else is just implementing interfaces. A different style, a different way of looking at it. This is very extensible. This is not going to be fragile because I'm only using this base report 2 thing just for this generate and do line. Everything else I'm building up from interfaces. So this is this is more composable style with a little bit of inheritance, just to show you can kind of mix it back and forth. If you've never seen a style like this before, here you go.
Process and do it in classes that are called stuff and data and information. Oh, you all act like you never wrote one, but I know you did. The reason you can't name them is they're the wrong size, and you should maybe split it up. What does it keep track of? What does it do?
Well, okay, so she's touching on this boop style stuff of modeling your domain in a little different way that allows for more flexible changes to come in.
This is all the way back to like CRC cards from 40 years ago, but if it's doing more than one thing, it probably is.
CRC's card is just saying, how do you define what these roles are? Who gets what? Who's using this? What data am I having? Who am I giving stuff to? Input, output, process. Okay.
More than one thing. How are you going to break it up? White space is again your friend. Sometimes there's comments, but there doesn't have to be. So here's all our private member variables, and here's a blank line, and then there's some more private member variables. Why? That is a note from the past. Maybe it's only from yesterday, but it's a note from the past, right? 2 thingies. Here's all our public member functions. Oh, sure, look, your special ones, your constructors, your destructors, then a blank line, then the good stuff. I get that. But why is your good stuff broken into 2 pieces? Because there's 2 pieces, right? I'm boring your watch to tell you what time it is, but okay, I'm showing you how to read watches. This is how it's done. Same with the gaps between the blocks of the code when you implement those functions. It's telling you about the grouping. All you need to do is read it. But people say to me, why are you breaking up my beautiful info?
See, this is when I came from a pure procedural C level thing, basic, coming in. I came up that way. And when I first encountered all this public-private stuff, I asked, that was my first question, why are you guys putting yourself through all this trouble of all this breaking everything up, making it more complicated and slowing it down? Making things private. And why not just have everything open and touching? It's like, that's fine, Chris, when it's like 2 or 3 people. But you start to get more than 3 people, it starts to become a problem communicating what we're trying to make with this damn thing and how it's supposed to work, and using idioms inside and protecting each other's stepping on each other's toes, and making it not so it's not fragile, so I can change this thing 6 months from now without breaking everything and spending 2 weeks trying to figure out where everything went wrong.
Information. It's so easy. That's why I'm breaking it up, because it's so easy. Okay? Because you just start using stuff like, hey, look, the font is right there. I'm going to use the font. That's going to be helpful. And you're taking a chance that you're breaking something else. We already say we don't want global mutable state. Why? It's so easy. If all our variables were globals, how easy life would be. No, because we would break stuff. When you separate things, you have a better design. When you have encapsulation, you have a better design. And when you're explicit about what's going across boundaries and you minimize what goes across boundaries, you have a better design.
She's talking about a better model, right? If you can separate things out, and usually it's by what's that law? It says by how you break up the code depending on how the company is set up. That kind of stuff. Work with it. There's a law for it. It'll come to me in a second.
So imagine I have a class that represents an employee, and it's full of stuff about that person as a human being. Their name, their birth date, where they live.
Conway's Law.
Stuff about their business relationship with you, your employee, their salary, how many hours they've worked this year, how much vacation they've used. And then some stuff about your and their shared relationship with the government. How many taxes you've already taken off and sent to the government on their behalf, that kind of thing. These are 3 separate things. If you have code that sends people birthday cards, I have vendors who send me birthday cards. I find it really creepy. I didn't give them my birthday so they could send me cards, but they do. But if you're going to send your employees birthday cards, that's different from writing up their tax paperwork at the end of the year, right?
Not creepy. It's sales. What are you talking about, lady?
So you say, I'm going to split my employee class into these 3 functions. That's great. Or into these 3 subclasses. But then where do I keep the functions? The chances are you're going to make a class called personal information. Employee will have a member variable, PI, which is their personal information. And another one with their tax stuff, another one with their salary stuff. And I need to write your tax slip at the end of the year. So that's a function in employee right now. Will I move it into one of these aggregated classes? Well, probably not, because there's outside code calling it, but I might just delegate, right? The function sitting in employee might do nothing but call the tax slips prepare method. But is it the tax slips prepare method, or is it the personal informations method? Like, you have to make a decision. Most of the time, it can be as simple as numerically.
See, these are the kinds of problems that are coming up when you're modeling with this class-oriented technique where you're still doing procedural stuff. It becomes very difficult to model this stuff, and you have to model it ahead of time. Ugh.
I use 7 things from this new.
I mean, you do have to think about it ahead of time, but like, and when you have to think about how you're going to add to the model, that's really hard to do ahead of time. But if you can set a system up that allows that to happen more easily, okay. But then there's the whole pre-optimization, right? You don't want to optimize too quickly. So what do? You build little toy versions of it. Even if you have another thing you're going to go attack, build slices. Build a couple vertical slices out of the damn thing. Find out what the problems are, and we could maybe do it a little different. I mean, the alternative is we're trying to go bang on something that's just too fragile. It's going to break. It can't get pushed anymore. You're making everybody mad, and everybody's getting burnt out. Well, try it. Maybe there's a different approach that Alan Kay's been yelling about for the last 40 years.
Smaller class and none from the others. Well, I guess it's a member function of that. Where it's kind of balanced, like your tax slip has your name and address on it, which is your personal information. Yeah, but this is about your taxes, right? So it goes in the taxes class.
See, this is the kind of thing where they're trying to figure out where to put, where to slot things. We're trying to figure out the tree category. It's just a dead-end approach. You just get super frustrated to try and model a system in this way, where you're trying to figure out which bag of namespaces to put a thing versus what it is. That's why this boop approach is like you'll have to go see my series, How to Program from the Ground Up, into the class-oriented program, because I go in deep into the differences. It's not obvious, and it's difficult to explain without diagrams.
Making the information that you're passing around obvious alerts you when you're taking a dependency that maybe you should not be taking. That's what's best about a good splitting up. Why do I need my home address to print my tax slip? Well, that's easy. In Canada, we're supposed to print the home address on the tax slip. Okay. But maybe in some other countries you don't do that, so you're like, why are you passing personal information in? You don't have to rearrange the inside of the class. It may be enough to rearrange those getters and setters that I said you shouldn't have run off to write. Imagine a huge class with all these getters. This has got something to do with displaying text on a screen, probably, right? We've got some XY coordinates, foreground and background color, actual text. And we have dozens of gets, dozens of sets, and then presumably a whole pile of like business logic as well. If you just leave the member variables alone, but change these gets so that they return little abstractions like location and appearance, it's much more obvious that you need to call them kind of in clumps. Probably everyone was calling get X and immediately then called get Y. Why not make a single call to location and get the X and Y? But only the X and Y. If you want to know the colors, you need to make another call. Makes it more obvious which things are using what out of this big interface. And this is about the constant change. If I need another parameter where I used to call get X and get Y, I'll just call get text now without really thinking. Now I have to think about it. Why do I need more information? Should I change location? Should there be more stuff in location that I could call? It gives you better design. Because when we're in a hurry, we just make it work.
Yeah. Yeah. So but when you're in a hurry, procedural is the way to go. For real. It has its place. And everything at the bottom, of course, is procedural. So we're all, at the bottom of everything is going to be imperative. But man, you can only go so far with that. Sometimes you have to slow down and fix things.
The idea behind abstraction is to protect you from accidental dependencies and rippling changes. And that's why you're putting these in place.
Yes.
I see that I very carefully arranged for power and then didn't actually, plug it into my laptop.
We're almost done, guys.
There you go. Okay. That's all right. I know what you need to do. Did you see it? It said call to action for a minute. And I will try to wake it up for the sake of the recording. Oh, it's really unhappy now. What I want you to do is to listen to the code when it's telling you that there are abstractions that are missing. Okay? Whether you wrote it or whether you're just reading it, it is telling you there's missing abstractions. And when you provide those missing abstractions, you're going to make the code better for you and for future people. You don't need to understand sales tax, nuclear reactors, chemical refineries, rental car business. You just need to look for those load-bearing white spaces, those names that are so similar, for what's clumped together and what's separate, and then just listen to the code. Now, don't be super mechanical about it. You do bring judgment to this. It is still important to be a designer and be together correctly, but don't be overwhelmed by it just automatically and say, well, I couldn't possibly because I could never design this system from scratch. That's fine. You don't have to design the system from scratch. You just have to listen to what the code is telling you. And most importantly, as you write stuff, you could leave some notes for the future, some blank lines, some comments, but you could also just take that note right now and work on it and make the code better right now, and that would be even better. Once you know to see them, those blank lines, those gaps, they are absolutely screaming at you. And all you got to do is listen, and I encourage you to do just that and look through your code for abstraction patterns. Thank you.
Yeah. So looking for patterns is good, but like doing a little design ahead of time and maybe thinking about a different approach that's not, oh god, all the performance. Okay, you can have the performance where it's important, but maybe there's a place where it's more important to have the ability to like modify and extend your code without going insane. I'm Chris Athanas. Give me a like and subscribe, and I'll talk to you soon.